So we're going to talk about degrees, minutes, seconds today. And for that to make sense, you see that a lot with GPS coordinates. So we're going to watch a quick little video to help us understand that.
Hey Brain Stuff, I'm Jonathan Strickland. So you've probably seen geographic coordinates like these before, maybe on a GPS device or maybe scrawled in a mysterious note you found in the glove box of a rental car. But if you never knew exactly what they meant, fear not. It's actually pretty simple, and we are here to make it all clear. When you see a set of geographic coordinates looking like this, or like this, you're reading latitude and longitude. Latitude represents north-south location, and longitude represents east-west location, usually listed in that order. By combining them, you can pinpoint any spot on the surface of the Earth. These coordinates aren't expressed in units of distance, but in degrees. Why? Because the Earth is a sphere. Imagine a line running from the equator to the center of the Earth, and then another line running from the center of the Earth to the North or South Pole. These two lines make a 90-degree angle. All latitudes in each hemisphere can be represented by drawing a third line somewhere between them. So the equator would have 0 degrees latitude, and the North Pole would have 90 degrees north latitude, and a location halfway between the North Pole and the equator would lie at 45 degrees north. Same thing for the southern hemisphere, except you'd call it degrees south. For more precision, each degree of the Earth's surface is divided evenly into 60 minutes, and each minute is divided into 60 seconds. If you need to get even more specific, you can just add decimals to your seconds. Alternately, you can write the whole coordinate in decimal notation. To do this, you have to convert minutes and seconds, which are base 60, into our regular base 10 counting system by dividing each unit by 60 and then summing them up. The results sometimes look counterintuitive, but if you're skeptical, you can pause the video and check out the math. Lines of longitude, also called meridians, run north-south and are used to measure position along the east-west axis. While the lines of latitude run parallel to each other, meridians converge at the poles and spread farthest apart at the equator, like the segments of an orange. Longitude is also measured in degrees, but its 0-degree line is known as the prime meridian, and it runs from the North Pole to the South Pole through Greenwich, England. So, if the prime meridian is 0 degrees, the opposite side of the Earth is 180 degrees, and lines in between are expressed as degrees east or degrees west, between 0 and 180. Since the lines of latitude are parallel, each degree covers about the same distance the world over, roughly 111 kilometers. But because meridians converge at the poles, the distance covered in each degree of longitude varies hugely depending on your latitude. At 20 degrees north, which is about the latitude of Cuba and Hawaii, 1 degree of longitude is approximately 104 kilometers. At 80 degrees north, the latitude of Svalbard and northern Greenland, it's only about 19 kilometers. So, let's say I wanted to go dig up a stash of hot loot from some coordinates I found written in a mysterious note. Even without looking at a map, we can start to make a guess where this would be. Since it's 43 degrees north, it's almost halfway between the equator and the North Pole, again halfway being 45 degrees. And since it's 89 degrees west, it's almost halfway west between the prime meridian and the opposite side of the globe, halfway being half of 180 degrees or 90 degrees. Based on this alone, you can guess it's probably somewhere in North America. But if we use a map or a digital tool like Google Earth, we can zoom in and see these coordinates lead us to the U.S. National Mustard Museum in Middleton, Wisconsin? Huh. Well, what's the weirdest landmark you've ever found on Google Earth?
Okay, so did you learn anything? Maybe? Okay. So let's talk about, so one of the reasons we have to know how to convert is that if we are given information in degrees, minutes, seconds, in order for us to do the math that we need to do, we have to convert it to decimals to do the math and then maybe convert it back. Why is it minutes and seconds when that's the same as time? Probably because it's base 60, but it still seems like maybe they could have used different words, and it may not sound so confusing, but they work like minutes and seconds do with time as well, so that's a good thing. All right, so it says some angles have decimal degrees. Okay, we know that. Angles with decimals can be expressed using degrees, minutes, second form, or DMS, in which the degrees are subdivided into minutes and seconds as follows. So 1 degree is 60 minutes. So a degree is kind of like an hour, but not really because they're completely different things. But 1 degree is 60 minutes, and 1 minute is 60 seconds. So 1 degree, or like 1 hour, would be how many seconds? Close. There you go, 3,600, 3,600. Okay. Your notations, so degrees, still degrees like it's always been, right, up high there. Minute is an apostrophe. Seconds is like a quote mark. And that's also how you do feet and inches, if you didn't know that. Okay? So that's your notation here. So let's look at how we're going to convert this. We're going to convert this 31.875 degrees to degree, minute, second form. And you don't have to worry about your calculator on this one, because I know y'all can push these buttons. I'll just tell you what the answers are so you can see the process here. So if it's 31.875, I know it's going to be 31 degrees and then something minutes, something seconds, right? So my first part of my answer is definitely 31 degrees. So I've used that part. So now I just take the decimal part, the 0.875, and I'm going to multiply that by 60. And when you multiply that by 60, you get 52.5. And since my board and the software and everything is updated, it doesn't like for me to do like dots, and I can't always do dot dots, so my decimals sometimes are kind of small. If you can't read it, let me know, but if I try any harder, it doesn't even look like a point, so I don't even know what to do anymore. All right, so basically this gives me 52.5 minutes, but I don't want that as a decimal, so that'll be my 52 minutes. So I've used this 52 part, so I have that 0.5 left over. Take the decimal again, multiply that by 60 to get my seconds, and what is 0.5 times 60? You don't need a calculator for that. 30. Okay, so we get 30, and that's 30 seconds. So 31.875 degrees is the same as 31 degrees, 52 minutes, 30 seconds. Okay? If this had been a decimal here, then we'd put the decimal in the seconds. That's the only one that should have a decimal. Okay? Make sense? Easy enough? All right. So let's look at number 1. So we've got 15.48 degrees. So I know that this is going to be 15 degrees, right? Then I'm going to take that 0.48 and I'm going to multiply it by 60. When I do that, I'm going to get 28.8. So I take that whole number of 28, and it becomes my 28 minutes. Then I take that 0.8, multiply it by 60, and that's going to give me 48. Oh, yeah. See, I can't do it in quotes either. And that's my answer. Easy enough? You don't round anything. You just take that whole number. This 28 went right here, and then this 0.8, I'm not rounding because I'm about to fix it and put it into seconds. Okay? Good question. Anything else? All right, so go ahead and, well, you should probably still have your calculator. Y'all do number 2. So if you get a whole number for the minutes, there aren't any seconds because it's just right on there, okay? Easy enough? All right. Y'all do number 3. Only place you should have decimals is in the seconds if there are any. Now, it's fine, and probably what I would have done on this even is actually type in the 0.26 times 60, but let's say this was 46.268372 blah, blah, blah. It kept on going, right? I would still take this 46 out here, but this continuous decimal, I couldn't round and then type back in. So at this step in my calculator, I could just do minus 46, then it leaves me with my decimal, and then I can multiply that by 60, right? Just manipulate your calculator so you get what you need. Any questions at all? All right. So if we need to go the other way, we have degrees, minutes, seconds, and I need to put it into decimals. This is more of what will come up more often for you. We're going to change it. So if I have 73 degrees, 9 minutes, 50 seconds, I know I'm going to have 73 point something, right? So I'm going to start out with my 73 there. So I'm going to take the minutes, which is 9. So to get that, I had to multiply by 60. So here I'm going to divide by 60. And 9 divided by 60 gives me 0.15. My seconds, which is 50, that actually got multiplied twice. Remember, that was like in my second step. So I'm not going to divide by 60. I'm going to divide by 60 times 60, which is 3,600. And when you do that here, you actually get a continuous decimal. It's something like 0.0138, blah, blah, blah. So what you would do in that case is just leave that in your calculator and then add it to it. You're going to add all this stuff up. So 73 plus 0.15 plus 0.0138. And then you get 73.164 degrees. So that's the process of how you get there. I'm actually going to show you a different way where you don't have to get all those intermediate numbers. Not a different way, it's the same thing, but like you're not going to actually get the decimal out over there, okay? So we're going to write each angle measure in decimal degree form. So I have this 315 degrees. I'm going to add to that, well, my minutes become whatever they are over 60, and I don't have any seconds, so you just put that in your calculator like that using that fraction button, and you're good to go. .133. Push the right buttons. Awesome. All right, so let's talk about what happens when you have a negative. You basically just ignore the negative, do your thing, and make sure you put the negative in on the end. Don't type the negative into the calculator, because then it's going to subtract things when you don't want to actually subtract things, and that doesn't make any sense, okay? So my setup here would be negative 121. And it's actually like big parentheses here. You're not going to, but if you don't use the negative, you won't need the parentheses in your calculator. So that's why doesn't make a difference here. I would add that to 4 over 60, and then add that to 45 over what? 3,600. And if you just don't put the negative in the calculator, you don't have to use these parentheses, and it'll give you the answer. Now, I love these little calculators you're using. Totally fine with you coming to tutorials or math time or whatever to use the calculators if you're not happy with what you have on your phone or whatever. But I do want to remind you that there is the desmos.com/scientific that has this little fraction button also and makes everything really nice. You can get this on your phone and your tablet so that if you're, I don't want you to be struggling just because of the calculators. The TIs are a little overrated if you ask me. All right. So this is negative 121.079 degrees. So make sure that that's actually what you got. And don't forget your negative in the end if you don't put it in the calculator. Okay, we good? All right, you do number 6 on your own. Then we'll be done unless you have questions. As always, type it in, make sure that's what you get. Don't just copy mine down. All right, any questions at all? All right, so let's talk about formative. Don't even bother opening your tablets because it's not live yet. I'm going to give you a paper worksheet, okay, and you've got some options here. So, in formative, what you have is going to look something like this, okay? This over here is exactly what you'll have in your hand, so if you can't really read this, you've got this, okay? And you have options. Some of you have touch screens, some of you don't. If you want to do your work in formative, that's fine. And because of the nature of this, I didn't even give this as an option last period, but somebody did it, and she was done before everybody else. In the show your work part, because you're not having to do any crazy math, you could totally just type your work. That's fine too. If you feel like that's faster for you, some of you be like, no, that ain't faster for me. Whatever, okay, you've got options here. But you're going to have to enter your answers as well. So like for number 1, and they're go along with those numbers so it won't make sense. On number 1, there's a place here for you to enter your answer. You can enter it. So let's say that you want to, you don't want to show your work in formative. You want to do it on the paper, and then I'll talk to you about what you're going to do. You could go and you could answer all these questions and then go back and take care of the work. That's totally fine. There's this little keyboard here. This is going to work better for you. Somebody had issues because they were trying to use the touchscreen keyboard on their tablet, or I don't know what keyboard they were trying to use, but it wouldn't let them do a space when they needed to, which was weird. But because you have to have degrees, minutes, seconds. The minutes and the seconds, that's just an apostrophe and a quote. You can totally use those keys on your phone or on the keyboard. But the degrees, if you just hit that little keyboard right there, you'll have a degree sign right here, and it'll take care of it for you. But make sure when you're doing the degrees, minutes, seconds, that if you notice how it's typed even, there's a space there. So you have the degrees, space, minutes, space, seconds. Okay, if you don't do that, it's going to count it wrong. And it wouldn't let him space after the minutes. I don't know why. But I made him back out of it, and then he used the degree sign from here, and then it seemed to be happy, so I have no idea what was going on there. But along the way, if I want to show my work, so here's just question 1, so it tells you what question you're on so you don't get confused. You can type the answer right there. It's the same thing as doing it on the other one. If you're going to do it all on here and you want to upload pictures, like we did on that first day, you're going to just go here and hit that picture button, and then take a photo. And I know when you were taking it on you, and that's what my camera's looking at apparently. I know when we were trying, you were like holding it up like this on your tablet. It was weird, but you could do all of this and enter all your answers on your tablet, and then maybe it's easier to go upload the pictures using your phone. But I would highly suggest you do that and do take a photo instead of taking the pictures and going to find where they're uploaded. That's very tedious sometimes, and this just kind of takes care of it for you. Or you could just over here type your work, or you could write your work if you have a touch screen or whatever, okay? Totally up to you. We good on that? Any questions? All right, so I'm going to hand these out. Go ahead and get started on this. Yeah. You have to put it informative, yes. But how you put it informative is up to you. So maybe you don't write on this at all because you're doing everything in there. I'm okay with that. But if you want to do it all on here and then transfer it into that, that's okay. All right. So I'm going to hand these out first because this isn't live yet because I wanted y'all listening to me and not trying to play around on here. I'm going to hand this out and then get started on this and then I'll go make it live.